Today's lesson is on solving equations, something you've been doing for years and you'll do for several years to come. Before we actually start solving equations, let's talk about what an equation is made up of. An equation is made up of two expressions, so we have to know what an expression is before we can get to an equation. An expression is a mathematical thing that is made up of either numbers, like this first one you see here, right here, or it could have numbers and variables, like you see down here, or it could have several variables and several numbers, and it could get really crazy. But an expression is made up of one or more terms. So you might ask yourself, well, what's a term? A term is a part of the expression. It could be a number by itself. It could be a variable by itself. It could be several variables pushed together, like you see right here, with a number in front of it, which is, by the way, it's called a coefficient. So if you look at this first expression right here, you'll see that this is one term. Here's a second term, and actually that negative goes with that term, so that term would be a negative 2x to the 6, y to the third z. And this last one is a positive, and there'd be a 1 right here if you wanted to, positive 1x to the fifth, y squared z to the fourth. Now, I want you to look at this one down here, because people see this one right here, and I'll ask you throughout the year, how many terms are there? And what we're looking for are plus signs or minus signs, because that's what separates terms. So I see two signs up here, a plus sign and a minus sign, so that means I have to have three terms. Well, I'll have people on this one down here say, well, there's a minus sign. Okay, this is going to sound weird, and it's kind of goofy, but I want you to think of parentheses as curtains. We can't really see in there, so we don't see that minus sign right now. All right, you're going to have to kind of stay with me here. So if you can't see in there, you don't see any plus signs or minus signs, so this is actually one term. So if I throughout the year, if I say how many terms are there and you see something like this, you would answer 1. Now what could we do to change that? Well, we could distribute. Now I don't really want the equal sign there because it's not an equation, we're not solving, but I'm just showing you that I distributed the 2 into the parentheses, and now I have 2 terms. So we had one term on this side, and when I distributed, we have 2 terms because now the parentheses is gone and I can see that minus sign. So I have one term is 8x squared and one term is 18, and they are not like terms. I hope you guys know what like terms are. One more review thing before we move on to the actual solving of equations, and let's review this one. PEMDAS. We all remember it. Please excuse my dear Aunt Sally is how I learned it, a little mnemonic that we learned when I was a kid. But I really don't like teaching PEMDAS in this way, because when you write it like this, PEMDAS, P-E-M-D-A-S, we know it's parentheses, exponents, multiplication, division, addition, subtraction. A lot of people, and I'm talking about adults here, get these kind of questions wrong all the time because they see M comes before D and they want to do multiplication before division, or they want to do addition before subtraction. And hopefully we all know that that's not how it is. So I like to look at PEMDAS in a different way. I like to think of PEMDAS as a big old pyramid where parentheses are the most important, so they're at the top. Exponents are on the next level down. Multiplication and division are the same level, and addition and subtraction are the same level. Now here's something that might blow your mind. Did you know that we really don't have division and we don't really have subtraction? Division is just multiplication, but multiplication with fractions. So people don't like fractions, so they would rather do division, and that's why we do division. Same thing with addition. We don't really have subtraction, we just add a positive number with a negative number, and then we do the subtraction there. So really, if you wanted to, you could really just think of everything as multiplication and addition and leave out division and subtraction, but you'd have to change it as you wrote the expression down. So if you wanted to remember PIMA, then you don't have to worry about that kind of stuff. All right, so let's go ahead and get started. So what does it mean to solve an equation? Well, what we're trying to do is we're trying to get the thing that we're solving for by itself on one side of the equal sign. So if I'm solving for x, at the end of it, I'm going to want it to look like this, x equals. Or if I'm solving for y, at the end I want it to be y equals. Could I have it the other way around and have the y on the other side or the x on the other side? Well, sure, they're the same thing. All right. Now, we could also solve for a number. I could end up having, say, hey, solve for 5, and you might have the answer that looks like this: 5 equals x minus 3. Now, we don't really ever do that, but I could, and maybe I will. So what does it mean if something is a solution to an equation? So if you had an equation that looks something like this: 3x plus 7 equals 4x minus 5, and I want to know, hey, is 3 a solution? Well, we would take the 3 over here and substitute it back in for the x's and work it out, simplifying each side. So what is this? 9 plus 7, that's 16. 12 minus 5 is, what's that, 7? And we'd go, nope, not a solution. So for it to be a solution, as you substitute it back into each side of the equation, both sides would have to be equal. Hence, it would be an equation. So sometimes the problem that we get into in math is we look at a problem and we go, oh my gosh, that is way too much information. I won't know how to do that. So the first thing I want you guys to do is to not freak out when you see something that looks hard. Usually in math, if you break it down into smaller parts, it ends up being a lot easier than you think it is. But if you stress from the beginning and kind of give up, then we're not going to get anywhere. So don't worry when something looks like this. I'm going to give you some steps on this next slide to get this to be a little bit easier. All right, so here are some questions that I came up with a few years ago, and I want you to write these questions down along with the possible answers. Maybe not the answers for number 1, but that's okay. So these are the questions you're going to ask yourself, and you're going to, in your head, going to answer those questions when you're working through solving an equation. So the first thing you want to do is, well, what am I solving for? What is the variable, or maybe, I guess, number that I want to get by itself at the very end? And once you answer that question, you ask yourself, well, how many of those letters, or numbers, I guess, do I see? If you see 1, then we're good. We can go ahead and solve. And you'll see that I put SADMEP there. It's kind of PEMDAS in reverse, because that's solving. PEMDAS is when there's no equal sign. SADMEP is when there is an equal sign. All right. So if you see 1x, let's say that we're solving for x, you only see 1 in the whole equation. That's good. We can go ahead and solve that just by doing the inverse operations, moving stuff around, and boom, we have an answer. If your answer is more than 1, like, I don't know, 2, 3, 4, well, that's bad. So we're going to have to get our variables together on one side. Well, to do that, and I should have brought this up before, is before we even ask these questions, you're going to want to simplify both sides of the equation. So don't even worry about moving stuff around. Simplifying, and this is easy simplifying for the most part. It's basically getting rid of a parenthesis and combining like terms. So usually you'll just have 1 or 2 terms on the left and 1 or 2 terms on the right after you simplify, and then go ahead and ask yourself these questions. All right. So if there's more than 1 x, that's bad. We're going to have to get those x's on the same side and go from there. So the next question is, are they like terms? If the answer is yes, that's good. We can combine those like terms and solve. We just do the SADMEP. If the answer is no, that's worse. We've gone from bad to having more than 1 x to worse. We can't even put them together. When we go from bad to worse, you have to factor. That's the only way that you're going to end up solving this. We'll get to factoring later on in these lessons. So just know that at some point, you're going to go from bad to worse. Know that all you have to do is factor. So let's go ahead and do one using those questions that I want you to do. Remember, the first thing you have to do is to simplify both sides of an equation. So over on the left side, I see that I have parentheses, so I'm going to go ahead and distribute the negative 3. I'm getting negative 6x minus 15, and on the other side, there are no parentheses, so we're just going to go ahead and leave it alone. And then I'm going to combine like terms. So I see a negative 4x and negative 6x. Well, those are like terms. Negative 10x minus 15. And on this side, I got a 2 with a negative 5. So it's negative 8x minus 3. Could you put negative 3 minus 8x? Yeah, we can move these around all we want to, as long as the sign stays with them. All right. So now that I see I have two terms on both sides, that's usually a good sign. So I ask myself the questions. What are we solving for? Well, we're solving for x. Well, how many do you see? I see two x's. Well, that's bad. All right, so now we have to get them on the same side. It does not matter which x you move. I personally like to move the smaller value x. So -10 is smaller than -8, so I'm going to move that. And why do I do that? Because my x will always be positive. If I move the -8 to the left, I'm going to have -2x, which is no big deal. It's just we'll have to divide by -2 at some point, and we're really good at losing negatives. So I'm going to move the -10 over to this side by making a positive 10x, and I cross it out on this side. I don't put the plus 10x on both sides, but you are more than welcome to do that. All right, so now I have -15. I'm going to combine these two like terms and get 2x minus 3. All right, so now I have 1x. That's good. I'm going to do SADMEP. Do I see any subtraction or addition? I do. I see this -3 right here, so I'm going to add it to the other side, cross it out, and I get -12 equals 2x. I'm going to divide both sides by 2, and I get x equals -6. Could I have wrote -6 equals x? Of course we could. And of course, we're going to put a box around our answer. And there you go. We've solved an equation that kind of looked difficult from the beginning, but it wasn't that bad. All right, so now that we're in Algebra 2 Honors, you got to understand that sometimes I'm going to give you an equation that may not actually work, which is kind of weird, which means you don't come up with an answer, or you come up with an infinite number of answers. When does that happen? Well, that happens when your x's cancel each other out and you end up not having any x's to solve for anymore. So what you're looking for is either a true statement or a false statement. If it's a true statement, it might look something like this. 15 equals 15. Or maybe 7 equals 7. Those are true statements. It's not a solution because I don't have an x anymore, but it's a true statement. If it's a true statement, then it means all values of the variable will make it true. So we would say all real solutions. Or actually, we should say infinitely many solutions, because there's too many to list. If it was false, it may end up looking like this. 0 equals 7, or -3 equals 12. Well, that's a false statement. That is not that 0 doesn't equal 7. That's just silly. So that means no value for the variable will make the equation true. So this would be no solution. I'm sure you guys have seen that answer before, but maybe not this one up here that is infinite solutions. Okay? Let's go ahead and see what that looks like. So here I have an equation again. It's not simplified, so we have to simplify before we can actually do the equation. So I have to distribute this -1 here. So I'm going to go ahead and rewrite this. -3x minus 2x plus 1. If you have to draw the arrows, please do, because a lot of times we'll lose that negative. It's one of the biggest mistakes that we make these days. All right, so there, I've gotten rid of parentheses. Now I got to combine like terms. -5x plus 1 equals -5x plus 1. Uh-oh, I already see a problem here. I'm going to move the x's to the same side because I'm going to go through, remember, I'm going to go through my questions. What am I solving for? Well, I'm solving for x. How many do I see? 1, 2. Oh, that's bad. Anything more than 1 is bad. So let's put them on the same side and see if we can get anything to work here. So I'm going to move this -5x over to this side just by changing its sign. Cross it out. Not, uh-oh, I have 0 x's. They cancel out, and I'm left with a +1. Let's see, I guess I put a +1 there. Equals a +1 here. I don't know why I put the positives, because I don't need them, but it's okay. This is a true statement. So this is the infinite solutions. There's too many to list. I ended it with a true statement. When my variable was gone, I'm done. So let's go ahead and end the lesson on everyone's favorite, fractions. If there is an equal sign, guys, let's get over fractions right now because we're going to see them all year long. We can't be afraid of them. But let me tell you that if there's an equal sign, life gets so much better. Now, before we get started, you have to understand that math is really big on hidden parentheses. So always, 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 guys, if I emphasize something, you might want to write it in your notes. Always put parentheses in the numerator or denominator if you see a plus sign or a minus sign in that numerator or denominator. So I'm going to put parentheses around this guy and parentheses around this guy, and there we go. So how can I make this a lot easier? There's some teachers that make you work through the whole thing with the fractions there. I'm not one of those teachers. One of the properties of equality says if you multiply everything by the same number in an equation, then you didn't change the equation, you just changed the way it looks. So what we need to find is the common denominator. So I see a 4, a 7, and a 14. I need the common denominator. If you're not real good at common denominators, what you could do is just take the biggest number and say, hey, is that the common denominator? 14? Well, 7 goes into 14, but 4 doesn't. So go to the next 14. Well, 2 14s make 28. Does 7 go into 28? Yes, it does. Does 4 go into 28? Yes, it does. So 28 is the guy. So now that you have parentheses around that, I want you to put a 28 in the numerator of each fraction. Kind of offset it a little bit, I guess. And then I want you to physically cross out the denominator with the thing you just wrote down and write what's left. Well, 4 goes into 28 7 times. 14 goes into 28 2 times. 7 goes into 28 4 times. Don't do any multiplication from here because you're going to lose negatives. Rewrite everything so it's nice and clear. So I got a 7 with a parentheses, x minus 3. Now that's not a 23x, so I'm going to put the 2 on the outside with a 3x on the inside, minus 4 times x plus 2. Now it's a pretty simple problem. I have to get rid of the parentheses through distribution. 7x minus 21, 6x minus 4x minus 8. This is the guy that we lose a lot, the negative there. All right, so things are still not simplified because I got like terms on the right hand side. 7x minus 21 equals 2x minus 8. All right, what am I solving for? X. How many are there? 2. That's bad. So let's move them let's get them all on the same side. So I'm going to move the 2x to the left by changing its sign. And now I have 5x minus 21 equals negative 8. Now I can do SADMEP. I see a subtraction, so I can move it over here by addition. And I get 5x equals, what's that, 13? And I could divide by 5, and I get x equals 13 fifths. And we leave it 13 fifths. Please don't write it 2 3/5. Don't write 2.6. We're big boys and girls now. We're in Algebra 2 honors. We leave our answers as a fraction. Unless it's a word problem, then sometimes a mixed number makes sense or a decimal makes sense. But in theoretical problems like this, always leave it as a improper fraction. And that ends this lesson.